Hello once again, 7th graders. So yesterday we started off Chapter 9, the number theory unit, and it said on yesterday's homework, I'm telling you, on yesterday's homework assignment, Paul was assigned the construction of Plusville, and some people got that wrong because they thought it was still talking about Tim, and they were writing down 1, 4, 9, 16, 25. No, this is Plusville. So when he's building Plusville, we wind up with all these numbers, everything between 1 plus 1 and 10 plus 10. So height-wise, we can see all of his buildings are going to be relatively easily defined as being one of these heights. So all the way up through 20. And can make it large enough. That's okay. All right, there should be one building. That's 2 because that's 1 plus 1. There's should be 2 buildings that are 3 centimeters tall. 2 plus 1 and 1 plus 2. And then there's going to be 3 buildings that are 4 centimeters tall. Was 1 plus 2, or excuse me, 1 plus 3, 2 plus 2, 3 plus 1. Then there's 4 buildings that are 5 centimeters tall. Think about it. 1 plus 4, 2 plus 3, 3 plus 2, and 4 plus 1. This keeps going up. Eventually, though, it's going to run out. Can you guess where we finally butt up against it? Or does it quit going up and start going down? Because I'll tell you what, when we get over here, there's only 1 over here on this side of it. What if we just counted up from this side? What if I got lazy? 6, 7, 8, 7, 8. I have 9 here, 9 here. Ooh, maybe it's 11. And indeed, that is what it is. 11 has 10 buildings, and from that point, it starts counting downwards. Think about it. 1 plus 10, 2 plus 9, 3 plus 8, 4 plus 7, all the way down to, you get 10 plus 1. Yeah, it's going to be 10 buildings. So, now, let's continue our discussion of these primes. One of the notes when Tim was taking down Miss Devine's notes and so forth, he asked, why is the whole number required to be positive? Well, quite simply put, and this is, if whole number x is a positive whole number factor of n, x is not larger than n. And we say that because if n is a whole number but not positive, it must be 0. Every whole number has a factor of 0. So this is going to fall apart. You see, like I said, yeah, factor 20, and so 5 is less than 20. That's fine. But I could say 0 times 5 equals 0. So in this case, now I've got a whole number that's actually less than the 5, and that's not supposed to be the case. I promised you that 5 is going to be less than n, or at least not larger than it. So that's why we say on the answer to this question right here, the whole number x is going to be a positive whole number divisor of n. Okay, so then there's this question here. Suppose n is a whole number such that n equals x times y, where x and y are both whole numbers larger than y and smaller than n, show that n must be some composite number. Now understand, when I'm talking about composite numbers, we're talking about numbers that are neither 0 nor 1, nor are they prime. And the explanation is right here as follows. Since n is equal to x times y, and x and y are both whole numbers larger than 1, we see that n has to be larger than 1. So n can't be 0 or 1, takes care of the first 2 conditions. And when the number of divisors of n has to be greater than or equal to 3, since 1, x, and n are different elements of the divisor set of n. Now y could be equal to x, so we can't always list it as another element of d sub n. But whatever the case, n is not possibly prime, and a number which is not 0, 1, or prime must be composite. So, moving ahead here, suppose that p and q are prime numbers, and that p equals q plus 1. Show that q must be 2 and p has to be 3. See, 2 is the only prime number that's even, since an even number is automatically a multiple of 2. Well, since p equals q plus 1, we see that q and p are consecutive whole numbers. They have to be. And so one has to be odd and one has to be even. This is true whenever we're dealing with this. When I've got p and q, they've got to be like this. If q is, got one added on to it, you get to p, they've got to be consecutive whole numbers. Since they're both primes, that only happens in one spot, and that's when you have 2 and 3. Those are the only consecutive prime numbers. See? And we can actually prove this algebraically. So when if I consider consecutive numbers n and n plus 1, if n is even, then n must be 2 times m for some whole number element, m, and n plus 1 equals 2m plus 1, which must be necessarily odd. Where on the other hand, if n is odd, then n is equal to 2k plus 1 for some whole number, we'll call it k this time. And n plus 1 would be 2k plus 1 plus 1. Well, 2k plus 1 plus 1 is 2k plus 2, which is 2 times k plus 1. 2 times some whole number, you got to have an even number. See? So, and that's how we're going to think about that. Now, as we look at this, after thinking Miss Devine's, item number 8, you decide to list all the whole numbers less than 101 whose prime factors are in the set of 2, 3, 5, and 7. If we were a live class, of course, I'd actually make you think about this, but and come up with the answers. Numbers that with just factors of 2 are going to include 2, 4, 8, 16, 32, 64. If I talk about just factors of 3, 9, 27, 81. Just factors of 5, it gets smaller. Just factors of, why did I write 24? That was silly. Just factors of 7 gets even smaller, well, not really even smaller, but definitely run out of space because I almost had one with the 5, 525. It could have gone to 125, but 749, the next number up is 343. That's way off the list. Now the numbers that have just factors of 2 and 3. If you have factors of just 2 and 3, in fact, what you have are multiples of 6. Think about it. 6, 12, 18, 24. Let's see. Now, I'm going to leave off the 30 because I want just 2 and 3, you understand? So I'm going to skip over that. I'll jump to 36. For the same reason, I'm going to jump over 42 because that divides by 7. So I go to 48, 54, and I skip over a few before arriving at 96. We'll talk more about that in a moment. So numbers with just 3 and 5 as factors. Well, 15, divisors of 15 that don't divide by anything else. And that's listed 15 and 75. Oops, I forgot about 45. 3 times 3 times 5 would work. That would work. And I say etc. Because we could keep on going with this list. We could say, list all the ones that are 2 and 5, just factors of 2 and 5. Again, we'd leave 30 off the list. We'd say 10, 20, 50. There's a few more. I skipped 40 there. You get the idea. Anyway, there are certain numbers, though, if I get to like 2, 3, 5, and 7, well, this is going to be an empty set. There's nothing that's going to be on that list. Same thing goes for 3, 5, and 7. If I say the factors of 3, 5, and 7, the smallest one's going to be 105, so that's empty. But if I do 2, 5, and 7, there's one number in the set of those numbers between 1 and 100. That's going to be 70, of course. So, anyway, consider those as you complete through exercise 10 on page 4 this weekend. And I will see you guys next Monday. Have a great weekend. And to be good for your parents, I will see you next time. Smash that